All right. Thanks, everybody. My name is Michael Labbé, and I am a multiplayer game dev. So I did a lot of consulting, so I work with a broad range of studios. And I do things like backend services, scalability, protocols, interop, networking, performance, engine development. And along the way, while I'm doing all that work, there's a tool I'm just like, oh, I wish I really had this tool the entire time. So I've made this tool now, and I'm going to be sharing it with everybody. So the simple problem is, when your data structures change, your code breaks. This is something I think you just encounter right away as a developer, right? You just kind of internalize this situation. And it's just like typical, not just development BS, but typical game development BS, where it's like, you have a save file, and it's versioned. And you change your structs, and then you have to update your versions, and it's just that wrangling between your structures and your types. Another example is in protocols, where you have to write your marshalling and unmarshalling functions to satisfy the encoding of your structures. And even in simple projects, you run into situations where you have a config file and you have to map that to a struct. So I made a tool. It's for code gen for systems engineers. It's called Grain DDL. The important part is the DDL stands for Data Definition Language. And it's a replacement for macros, templates, and metaprogramming for code generation. So it works with any language. I've used it with C, Go, Rust, Odin, and Lua. And I think the simplest thing to do is just show a demo. So who wants to see some demos today? All right, I hope everyone in the back row can see this text, because we're going to define some values for a game today. Please let me know if I need to make this a little larger. You're good? Thank you.
A little bit more. A little larger.
OK. Damage per bullet equals 10. I'm going to explain what the heck is happening on the right in just a second. Right. So as I'm typing on the left, you're seeing some code generated on the right here. And so on the left, I have a struct definition for a weapon, damage per bullet. You can see a parallel struct here on the right. The output generates a function called weapon pack, which packs all of that, and then an unpack, which does the opposite, taking it out of a byte stream. Now, we're making a first-person shooter. So struct pistol copies weapon. When I do this, it creates a function that returns the values. From there, we can override a specific field and inherit the other one. So let's say the pistol takes 500 milliseconds, and now you can see that value is generated here. I'm going to do one more today. Struct shotgun, of course, copies weapon. And in this case, in a serious game, a lot of times you have interdependencies between your balance values. So you want to make the shotgun be a multiple of the reload of the pistol. Previously, a lot of people use things like spreadsheets for this. But spreadsheets don't have types that map very well to C, and there's a little bit of a struggle there with the code generation. So I'm very happy to say that you can do something like struct reload ms equals pistol reload ms times 2. And we look down here, you can see reload is double. And if I go over here to this reload and I change this value, it will update and reflow that in real time. It's kind of nice to have. So I just want to hammer a point home. I'm going to make one more field. I8 clip size equals 10. You add that, and you can see it's added to the struct. It's added to the pack, added to the unpack, and it's added to the fields in all of the weapon copies. So that gets to a point where your data structures are always in sync with your types, with your code. It solves the problem of automatic breakage. Now, there are other tools that do things like this. A couple of key examples that come to mind for me are protobufs or flat buffers. Now, the last time I looked at the flat buffer source code, it hard-coded all of those things in there. So like, for instance, I went in there and it was doing protocols. There was just a bunch of cout calls that were outputting protocols to a stream. And that's cool, right? They focus on protocols. But nothing here is hard-coded. You should be able to generate whatever you want for your projects. So there's a tab I am going to draw your attention to. CG Temple. This stands for Code Generation Templates. I'm going to click over to this, and you can see there's a templating language. And so with this templating language, you can generate whatever you want. So this produces the output. So I'm going to do the obvious thing and delete it. The best feeling in the world, delete your code. And I'm going to generate for you a Lua set of definitions for that live. Just want to be clear, we still have the structs. They're all still there. And I'm going to output some Lua. So let's see, range struct dot name equals dot. Let's close that off. Oh, here it goes here. Range fields. I like to start with the end, so let's put the comma, the trailing comma. Emit a tab dot name equals dot value. So there you have it. Just live. Thank you. Thank you. So live, you can generate, just like that, you can generate code in other languages. And so it's really good for interop. And it's really fun. I gotta admit, it's really fun. Like you're sitting there, you're writing like 5 lines of code at the same time, right? Like you're just letting it rip. And it's a lot of fun, but there is an elephant in the room with code generation templates. And why I think it's been rejected by most large or serious projects is because they actually suck to maintain. As of right now, there's a lot of different templates out there. Some of the popular ones are Jinja, gets used in the CMS world a lot. Go templates get used with Helm, so that's a big popular one. And then Mustache has a lot of implementations. So those are 3 examples. Actually, show of hands, who's used one of the 3 templating ones? Okay, all right. Who here has encountered somebody else's and liked it? All right, so I'm onto something. All right, so the reason I wrote this IDE isn't because I have something to say about IDEs in general. I think there are other people working on some pretty fantastic editors. But what I'm focused on specifically is the idea that we want to make template generation maintainable for teams. So I'll give you the first example of something you can do here. I think you've already seen this, but you can just get results in real time. So I can take a value and then multiply it by 4 and plus 2, and then the results are right there. You can see it impact everything. So it answers the key problem that I think you run into when you see somebody else's template, which is, why is that character there? Like, what put that character there? And the second thing, it didn't quite make the roadmap. It doesn't make the demo yet. It's on the roadmap, but source map debugging for templates. So you're going to be able to click on any character and go, what are the set of expressions that produce that character? And thirdly, this is actually running in a browser. So the reason I did this in a browser, go get them. Yeah, I know. It's on fire. The reason I did this in a browser is because I was inspired by Compiler Explorer, where you can take a link and share it with your friends, so that way you can start to create a set of templates that fit a set of standards. You can communicate your data structures that way, and there's a longer term vision there about interoperability and having teams be able to communicate through their types and how it gets used as 2 separate articulations. Secondly, this is something that I feel pretty strongly about, is I find a lot of projects, when someone asks you to use their software, they oversell it. And they get into a situation where you're like, you download it and then you realize after about half an hour it's not for you. And so I really despise false starts. I want people to be able to just go to a web page, decide if they like it or not, decide if this is a match for them. And then if it is, then they can download it. All right, that is the demo side, but I've got a little more for you. So I want to show some examples of how this is being used. I think there's some pretty clear and obvious uses around serialization, templates, things like that. Network protocols are an obvious use. I love it for that. But I'm approaching this with a lot of humility because I've given this to a few testers. And they've used it in ways that surprise me. So they're awesome, and I want to show some examples from that. So here's the first example. Show of hands, who here is familiar with ImHex? Fantastic. Okay, this is a highly recommended tool. It bills itself as a hex editor for reverse engineering. Looks like this. You're not going to be able to read that from the back. But I just want you to sort of take away what this is. It's a hex editor. The important thing is you can see there's colors. I can't put the correct. There's colors over there, and that delineates the different fields in the hex editor. Now, this is a fantastic feature. You can just hover your mouse over them. And when you hover your mouse over them, you get to see what fields they belong to. And there's a pattern editor where you can define them. So where does the DDL come in? If you define your types in this, it for free gives you a pattern editor, so you can go through it. So anything you serialize to disk, you can now walk through and debug. This is an example of something dumb that I did, where I had a file on the disk, and I got a bunch of 4s. And you'd be surprised how often something like this happens. I just had a whole bunch of 4s show up in my binary file. So getting that for free is really nice. That's a big forehead slapper for me there. Moving on. Language interop. So it's really fantastic. It's a data definition tool more than an interface definition language, but it works for this purpose. So a good example is WebAssembly on a web page. So if you've worked with WebAssembly, you get a linear blob of memory. It's contiguous. And you can use JavaScript to read out of the blob. But the problem is your code has to stay in sync. So what you can do here is generate code in both languages that serve the other one to get this result. And that really helps. So I'll give you an example of some code you can generate. This is the C side. You got to keep this in mind. Basically, there's a struct here. It's just a couple of simple types. And then we generate a function that returns the offset of the field in that struct. So this will return 0, and the next one below it will return a number that's pretty close to 0, probably 4. That's C code. It's generating this export name is just the name of the function. And then we generate an object in JavaScript that takes in the WebAssembly linear address space and a pointer offsetting into that address space. There we go. It's right on time. And it calls that in constructor, caching all the offsets of those fields, like I said. And then it does getters and setters for each field. Now, you always have the ability to set and get your JavaScript, your C objects from JavaScript. Credit to Gabriel for coming up with this one. This one wasn't on my radar. I have one more example for you. We're going to do a game where we have a 10-kilometer racetrack mesh, and we store it in 8 kilobytes. Now, you can't store a 10-kilometer track that's anything close to something somebody would want to drive on in 8 kilobytes. But the trick is you don't store the mesh at all. You just store how the mesh is distorted. So you have to imagine a procedural track going down an axis. You just procedurally generate a default mesh. So 0 kilobytes stored on the disk at this point. And then you use modifiers in the sense of 3D Studio Max or Blender that deform that mesh. And that's what you store in the binary file. So in this particular situation, you would store like a curve or a bump in the road or something like that. Here's a simplified mesh that just shows what the procedural generation would be. And here's an example of a curve set of parameters, start, length, and then some parameter about how the curve works. And so where does the DDL fit in for this? Well, you can use the DDL to define the Lua API, which is how the level format gets created. Then you can generate an asset baking tool that converts that into a binary. Then it generates a C loader, which you can put into your engine. And one of the other things it does along that way is it does an AOS to SOA transform, which has the property of keeping similar bytes next to each other. So when you feed that into a Brotli compressor or similar, it does a very good packing of that. And the result is a racetrack that fits in about 8 kilobytes. So what you're actually storing is just a bunch of those parameters. All right, so right now, because there are so many use cases for something like this, it is in closed testing. So I'm accepting users for closed testing. And if you're in this room and make game tech, I would be happy to talk to you today. But in terms of what happens, because build dependencies are a headache all the time. So I want to highlight I've tried to make this as painless as possible. It's an 300 kilobyte standalone executable. It's SimShip. My commitment is I SimShip every version on Mac OS, Linux, and Windows, and it runs on all of the standard architectures that you'd expect. You don't need a package manager. I want you to check it into your source control. It's so small that I think you can just get away with that. And there's no compiler toolchain dependency, which means if you have a lot of developers and you have a lot of operating systems, you don't have to worry about versioning or CI. It's just stick the exe in there. So that's what the impact of it will be on your project. So this would be where you would apply. And I want to thank everyone for your time, and I'd be happy to take your questions.
Hello. I'm really keen to use this for generating JavaScript bindings for WebAssembly stuff, because like the only other option basically is using this massive mscripted blob, which you're looking at like a megabyte of just like JavaScript machinery to get it to work out of the box. One of the things that I've had trouble with though is that like type sizes and padding is like often completely different between like the C side and the WebAssembly side. Like the pointers are different sizes, the padding in the struct ends up being completely different. And at the moment, the only way that I can like be guaranteed that it's going to be correct is like looking at the output from Clang. So like, do you have a idea of like how to handle the different like sizes and base types and stuff between WebAssembly and say C?
So a data definition language at its core doesn't know what the C compiler is going to do in a subsequent step as far as the alignment and padding will be. But you have the ability to generate functions that return that information, and then you can introspect at runtime. So that's how I would approach that.
Like one of my favorite things about like something like Protobuf is that it has like a backwards compatibility component to it, which is related to the fact that it has like durable tags per field and stuff like that. It seems like for you to be able to do a similar thing in this language, you would have to extend the DDL like actual syntax layer, unless you already have some kind of extensibility model related to like metadata attached to fields.
So that's an interesting question. I didn't get into here because I wanted to just explain the essence of what I had before getting into the nuts and bolts of it. But there's a format where you can define arbitrary attributes that attach to fields. And you can use that information. And there's going to be a very simple standard library which allows you to do things like deprecate fields. But it turns out across domains, if you start to work on versioning, it's very fraught with context-specific things. So I think when you're designing a language, you really want to get into what is in the standard library versus what is something that is best left to example code. And I think there's really no perfect answer to that question, but it really goes down to sort of you want to have a small number of attributes that people can use and build off of.
So what kind of technologies are you building on, like to be able to ship on multiple platforms?
So this is written in C99. It compiles in Clang with dash no standard inc, no standard lib. So basically, there's no headers from standard lib anywhere. And one of the reasons it works in WebAssembly is because it's literally the entire thing is just code that I wrote in C that has no bindings to anything other than the exports that I wrote. So the entire compiler and parser was handwritten and doesn't use a parser generator. And yeah, and then some of the test harnesses that run on that are written in Go.
So for multi-platform, I guess the IDE part that's just in the browser as opposed to multiple platforms.
Yeah, the IDE part is written in the browser, and it's the WebAssembly bit that runs in there, and then there's just some vanilla JS around it that uses the code mirror editor. So it's fairly similar to Compiler Explorer in that case.
So you showed kind of on the left, not the code template language, but the language of the structs. And I was kind of wondering what the full language was. Like, what are the things you can put on the left other than like these struct definitions?
Principally, it is a declaration-based language. You can do expression evaluation. So you can do things. If you can do it in C with bit shifting and things like that, you can do it here. It handles overflow at compile time, since All of the expressions will evaluate at compile time, so unlike C, where there's a runtime component, you can know if there's a type overflow. So we handle that correctly. It is ultimately a declaration language. There's semantic support for bit fields, so you have the ability to set bit fields and bit sets, and they don't turn into indices or anything, so you can actually get your names of the individual bits out at code generation time. There's something like select, or like enum on steroids called selects as well. So those are the sort of the three main aggregate types. But ultimately, your definitions look like structs, selects, and bit fields, and arrays of them as fields.
Thank you very much.
Thank you.